My name is Gwen Williams. This presentation focuses on historical records of tropical storms and how they provide some of the earliest evidence of rising temperatures in seawater. The two regions I am focusing on are the Indian Ocean, where these storms are called cyclones, and the Gulf of Mexico, where they're referred to as hurricanes. Now, there seems to have been a trend of more tropical storms occurring in these regions, with records constantly being broken for wind speed, storm diameter, and other variables, partly because that data is now scientifically measurable. When disasters like these were first being recorded and observed, information like this was not known in the scientific community. But let's not forget about a key ingredient: surface temperature. We now know that for a cyclone or hurricane to form, the seawater it forms in must be at least 27 degrees Celsius or 80 degrees Fahrenheit. In addition, the atmospheric pressure must be lower than 980 millibars or 28.94 inches of mercury. So how were humans able to report the destructiveness of these storms, and how can this be evidence to explain warmer surface temperatures over time? Karinga, present-day Andhra Pradesh, India, November 1839. This bustling port city on the Bay of Bengal no longer exists, as most of it was wiped out in the second deadliest cyclone in recorded history, with reports of around 300,000 fatalities and nearly 20,000 vessels and structures destroyed. It was so bad that residents didn't bother to rebuild. It's worth mentioning that a less devastating storm had struck the same area half a decade earlier, killing 20,000 people. There are no known photographs or drawings of Karinga, but de-sketched maps from circa 1774, pictured in figures 3 and 4, give an idea on where the city was located. This 1840 ship log, courtesy of the Asiatic Society of Bengal, indicates that in the days leading up to the cyclone, there was an increase in wind, precipitation, and decreasing pressure. Unfortunately, none of the observations in that log say anything about the sea temperature, just the air temperature. Two other things of note. Number one, India didn't have any public forecasting until the creation of the India Meteorological Department in 1875. Number two, the pressure recorded in the ship log is higher than the maximum pressure in which most cyclones and hurricanes form, per the Saffir-Simpson scale, which no longer incorporates pressure as a factor in their categories of storms. Galveston, Texas, USA, September 8, 1900. Also known informally as the Great Galveston Hurricane, this is the deadliest natural disaster in American history, resulting in at least 8,000 confirmed deaths. The damage was so big it could be felt as far inland as southern Houston, as shown by this headline from the area's dominant newspaper at the time, the Houston Post. Photography and journalism became popular around this time too, and weather forecasting was in its early stages. Louise Hopkins, a Galveston resident who was 7 years old at the time, recalled in a 1982 interview, quote, "It was right there at the front door, and then it began to get bigger and wider and was coming into the garden that my mother had. That distressed me to think she had so little time for these things and then to have them ruined that way." Unlike the Karinga cyclone, Galveston was able to slowly rebuild. In fact, they raised the city's grade by 2 to 3 meters and built a seawall. This proved to be useful when another hurricane struck the city again in 1915. That brings us to another point. Whenever a storm strikes, its path is often compared to previous ones that impacted the same region, and historical maps are particularly useful for this. The map on the left shows the relative path the 1900 storm took as it approached the Gulf of Mexico and touched down on Galveston Bay. Meteorologists and journalists alike have frequently compared this storm to other hurricanes such as Ike in 2008, Harvey in 2017, and Beryl in 2024, pictured to the right. We can infer that during both the storms of 1839 and 1900, the water had to be warm. Evidence from past hurricane and cyclone events is evidence of warming seawater. Of course, advancement over time in scientific technology, research, and data collections have now given us a bigger picture. Historical data from the National Oceanic and Atmospheric Association, or NOAA, obtained in a 2021 study by Kelly Swindle, indicates that seawater of the 19 Galveston hurricane was about 28 degrees Celsius or 82 degrees Fahrenheit. Today, improvements in forecasting and increased awareness for storm preparations have resulted in fewer fatalities from storms. Despite this, they still cause collateral amounts of damage, and the preparation efforts aren't always successful, as storm damage can occasionally get into areas that aren't considered to be prone, as shown recently with Hurricane Helene. But we can learn from the past what happens when these communities are not prepared and how they've responded. And as our oceans continue to get warmer and the overarching threats posed by climate change continue, such historical records of these storms offer a warning sign on what's yet to come.